All right. So acceleration, like I said, just a few slides. Five mainly. Let's set up my slideshow. There we go. All right, so what is acceleration? All right, so acceleration is the rate at which a velocity changes over time. So how does a velocity change over time? That's acceleration. All right, that's it. The rate at which the velocity changes over time. Okay. The rate of, now, we've talked about velocity, all right, and we talked about speed. Do you guys happen to remember what's the difference between velocity and speed? Well, hopefully you remember. Velocity has a direction. Velocity has a direction. Speed does not. Okay. That's the only difference between velocity and speed. So the rate at which velocity changes over time. Okay. Now, acceleration can change if someone speeds up, someone slows down, or someone changes direction. Those are the only three things where acceleration will change. So speeding up, let's say you're in a car and the car accelerates. That's acceleration. What's kind of tricky is when you're slowing down, that's another form of acceleration. We call it deceleration, right? It's just another form of acceleration. You're just slowing down. All right. And the third one is you're changing directions. As we just said, velocity is changing direction. All right. So if you look at this, as if you continue to change your velocity, well, that's going to affect the acceleration. All right. So acceleration will change if the speed increases, speed decreases, direction changes. All right. So the next few slides just kind of talks about these three items. All right. You don't have to take notes on the next two slides. But we're focusing on these three items. So speed, change in speed. Like I said, don't need to copy this down, just showing you guys. All right, so you can speed up. All right, so here's another example of a bicyclist. He's increasing speed 1 meter per second every second. All right, so that's increasing. Or you can decrease, all right, slowing down. Change in direction, all right. And here's an example, all right. So if you're going in a racetrack, when you're going in a racetrack, the velocity will always change its direction, which also affects the acceleration. All right. So you can be traveling in a constant speed, a constant velocity. However, since you're always changing direction, that's always going to change your acceleration. Always, always, always. And this is uniform UCM. I call them UCMs. Fun fact: I actually just taught my physics class this. All right, so if you ever take physics, you're going to learn about some UCMs, driving in circles. It's pretty awesome stuff. All right, but the key takeaway is change in direction. If you anytime you change in direction, your acceleration is going to change. Now there's an equation, okay? And this is the equation I want you guys to write down. Acceleration is equal to the final velocity minus the initial velocity over time. Okay. Acceleration is equal to the final velocity minus initial velocity over time. Okay, so hopefully you got that equation down. So let's check out an example. Were you guys able to get that equation down? Sweet. Let's check out an example. A man goes running 20 meters per second to stopping in 0.5 seconds. Holy smokes. That's pretty crazy, actually. What was his acceleration? So he goes from running 20 meters per second to stopping in 0.5 seconds. So let's analyze this. Let's analyze this real quick. I'm going to zoom out a little bit. There's my equation. All right. Acceleration is equal to final velocity minus initial velocity over time. So a man goes from running 20 meters per second to stopping. So what was his final velocity? Well, his final velocity was when he stopped, right? When you're stopped, your velocity is 0. What was his initial velocity? Well, the man goes from running 20 meters per second. So his initial velocity was 20. And then I have to divide that by my time. So my time here is 0.5. So now you just plug that in a calculator. All right? You can just plug that in a calculator. So you have negative 20 divided by 0.5. Now, most cases, acceleration's unit is meters per second squared. I'll zoom in a little bit. Acceleration is meters over seconds squared. That's the unit. And that's how you solve this type of problem. All right. However, sometimes, like this next example, your units change. So just be careful. Just be careful. Okay. Check this out. A car merging onto a highway goes from 10 kilometers per hour to 80 kilometers per hour in 2 seconds. What was his acceleration? All right. Well, looking at our equation, he goes from 10 to 80. So his final velocity, I'm going to work up here, was 80 kilometers per hour. I'm going to actually put that kilometers per hour minus his initial. Well, he started at 10 kilometers per hour. And we're going to divide that by the time. Well, the time was 2 seconds. So plugging into my equation, that's what you get. Okay. So 80 minus 10 is 70 kilometers per hour over 2 seconds. 70 divided by 2 is 35. Now, my unit My unit, well, I have km, kilometers per hour, divided by seconds. So that's a tricky one. That's my unit right there. And that's how you solve acceleration. Final velocity minus initial velocity over time. All right, one last practice problem. What would the final speed of a skater be who accelerates at a rate of 2 meters per second squared from rest for 3.5 seconds? There's a lot of information here. There's a lot of information. Okay. All right, so we know acceleration is equal to the final velocity minus the initial velocity, and that's all over time. Okay, I just wrote out the equation. So we know that's our equation. In this problem, it says, what is the final speed? What's the final velocity? That's what we're solving for right there. All right. If a skater who accelerates at a rate of 2, so he accelerates. So I know my acceleration. I know 2 is equal to, I don't know my final velocity. That's what I'm solving for. Minus from rest. If he is accelerating from rest, well, rest means my initial velocity is 0. All over time, my time is 3.5. Okay, well, mine is 0. That doesn't affect anything. So how can I get final velocity by itself? Well, the opposite of dividing by 3.5 is multiplying by 3.5. So you're going to do that on both sides. Those two cancel. My final velocity is equal to 7 meters per second. Okay, my final velocity is equal to 7 meters per second. Is there any questions on that? How do you guys feel on acceleration? Pretty straightforward. All right. All right. So for the rest of the time, all right, if you have been able to keep up on the assignments this week, you're golden. All right. If you are caught up on everything, what I did was I posted a little practice. It is ungraded. All right. I am not grading it. It's just practice. Okay. But what I did was I posted in the classwork tab, it even says ungraded. Ungraded speed, velocity, acceleration, escape room. Okay. Where you can go to this link. All right. Go to the link. And it'll take you to this escape room. You can click next. All right. So level 1 is this. However, I got to solve my level 1 problems. Here's level 1. Question 1, 2, 3, 4. Train travels north at 103. This is an example of velocity, speed, acceleration, or speed and acceleration. Well, hopefully, since you know it has a direction and just kilometers per hour, that's velocity. Okay. So you can do the escape room. All right. We've done escape rooms before, so you kind of know how it works. You go level 1, you're going to get a code. You plug in your code. It'll tell you if you're right or wrong. If you're right, you'll go to level 2, answer some questions. Okay. Now, that's if you were able to get everything done. Now, if you were not able to get any, let's say you're still working on the car lab. Perfect. Try to get that done today. Okay. You got about 25 minutes. If you need more time on the motion lab that you guys did today, walking, getting the times for the walking or the graph, you got time to work on that. Let's see what else. Car lab, motion lab, the motion FET activity where you had the friction and the two guys pulling the rope. You can work on that. Okay, so today's kind of a work day. Now that you know acceleration, I will be on the Google Meet the entire class period. So if you have any questions on any of the assignments that you guys have to do, just ask. All right, I'll be here. If not, I hope you guys have a great weekend, and I look forward to. I'm super pumped to see you guys on Monday. Does that sound like a plan? Sweet, awesome. We'll see you guys later.